All right, so welcome back. So this is our last topic in Unit 3. We're talking about the derivatives of an inverse function. So let's quickly review what an inverse function is. Inverse functions are functions where the following is true. You have f of x, you have 1, 4, 2, 5, 3, 6, 4, 7. G of x is inverse if we can switch the x and y's and say it's 4, 1, 5, 2, 6, 3, 7, 4. So it's just simply the switching of the x and y's that makes it an inverse function. You should have talked about how to find algebraic inverses for numerous examples throughout your academic career, starting first in Algebra 1, Algebra 2, Pre-Calc, all those classes included in some contexts. Now, sometimes it's pretty easy to do that. So again, algebraically, finding the inverse of 3x plus 2 to become x minus 2 over 3 is pretty straightforward. Just a matter of simply rewriting the function as y, switching x and y, and solving for the new y. This only works, though, if we're able to have a single variable that's solved for. If we have something like f of x is x cubed plus x plus 1, that process can be rather difficult, if certain times just downright impossible. So if we want to talk about derivatives of the inverse, typically we can't talk about the actual function of the derivative of the inverse, and so we talk about the value of the derivative of the inverse. And that's what this formula right here is showing us. Now, sometimes I'll write the notation as f inverse like that, prime of x, so it's the derivative of the inverse. I typically use a g of x a lot of times just to make it a little bit easier, or the test will tell you the same thing, like g of x is the inverse of f, and then the derivative of g is based off 1 over f prime of g of x. So what you might be thinking is, well, wait a minute. If I can't find the actual inverse function, how am I going to find the value of the inverse function? And again, goes back to that beginning thing where we had talked about the x and y's are just simply switched. Meaning, if I know that f of 2 is equal to 7, that means g of 7 is equal to 2. And that's the whole premise that I'm going to do to solve these problems. Because if I wanted to find what g prime at 7 was, I know that g of 7 comes out to 2 because f of 2 is 7. Well, now I'm doing is just 1 over f prime at 2. Now it's like, oh, I have my original function f of x. I can take that derivative. I can substitute into that derivative. Now I've got my answer. Algebraically, doesn't really work too well because you kind of can't find the actual algebraic g of x function for most problems. But numerically, it will work out perfectly fine. So this is what I mean. So there's your more formal notation, the inverse derivative written out like that. It's the same thing as saying what's g prime of a. So we want to find g prime at 4. That's the goal. So g prime at 4 would equal 1 over f prime at g of 4. So g of 4 equals some unknown blank. That means f of that same blank has to equal 4. And for most of these questions, it's going to be very obvious. You're just going to kind of substitute. Typically, it's 1, 0, negative 1. Something along those three is what will work out pretty easily. And we can look at this pretty quickly and go, x cubed plus x plus 2, 1 cubed plus 1 plus 2 is 4. So f of 1 would be 4, which means g of 4 is equal to 1. Because again, the inverse just switches the x's and y's. So g prime at 4 would just be 1 over f prime at 1. Well, again, I don't know what g of x is. I can't find that. I can't find its derivative, but I can find the derivative of f. F prime would just simply be 3x squared plus 1. So f prime at 1, 3 times 1 squared plus 1 is going to be simply 4. So g prime at 4 would be 1 over 4. Not going to always be the same number as what you have on the inside, so don't rely on that. That just kind of happened to work out in this particular case. All right, we'll do another one, just kind of give you the idea of just kind of what's going on here. But that's the process, really. Whether you're given a function or you're given more of kind of like a table of values kind of scenario, that's what you're doing. You're trying to see which one switches it out to be able to sub back into the problem. So again, here is this function right here. They want to essentially find g prime at 3, which means we want 1 over f prime at g of 3. So g of 3, we don't know what that's equal to, but we know f of something has to equal 3. And if we look at our values of x here, we can look and go, x equals 0. Perfect answer. If x is 0, 3 times 0 cubed plus 6 times 0 plus 3, that's just simply 3. Which means g of 3 is equal to 0 because they switch. So it's 1 over f prime at 0. Again, it's something obvious. Like if we wanted to work with a 1, you would see that it would be 3 plus 9, so it would be a 12. That's how that would work there. If I wanted to be like a negative 1, you would see it be a negative 6 is what we'd be working with. Something that's simple and obvious. You're not going to have a situation where it's going to be some bizarre number that just doesn't make any sort of sense. So you have to go through a crazy calculation for it. It's going to simply be like an obvious 0 and 1 are the two most popular. Negative 1 is also relatively popular. Same thing with 2, small numbers, something you can easily visualize and see. So our derivative of f of x would be 9x squared plus 6. So f prime at 0 would be 9 times 0 squared plus 6, which is just 6. So our final answer is 1/6. All right, so that's our inverse functions. And like I said, they could have given this in a table format instead, where, again, using the table of values, you're kind of doing the exact same stuff. You just don't have these functions to work with, but you will have values for f of x, values for f prime of x. You'll be able to recognize how one of them is going to switch to kind of create what you're looking for. All right, so let's take a look at an example of one of those tables. So here we have this nice table here with x is going from 0 to 6 and function and derivative values for f of x here. Now, we're still defining g of x as the inverse function. We won't find the derivative at 5, which means, according to our calculus rule, we're doing 1 over f prime at g of 5. So, well, like we looked at the algebraic problems, we're looking for the value of g of 5, which we don't know. But we do know that f of whatever that number that would fill in there has to equal 5. Now, the equations, we looked at an equation and kind of solved it out, figured out logically what number would fit for that scenario. Table, we don't need to do that. We just need to find the appropriate location on the table. Where is f equal to 5 on the table? That's right here at x equals 2. So f of 2 is equal to 5, which means g of 5 is equal to 2 because, again, the x and y's are going to switch each other. So we get 1 over f prime at 2, which f prime at 2 is 4, so our final answer is 1/4. And that's really how simple the table is going to work. All the information is right there. The key is just making sure you don't get distracted or you pick the wrong number. You kind of get trapped almost. So let's take a look at another example. Same table, but now we're talking about g prime at 2. So that means we want 1 over f prime at g of 2. So once again, we're looking for what g of 2 is equal to. That's based on f of some numbering equal to 2. So we look through our entire table. We look for when f of x is equal to 2, which is right here, at x equals 6, which means g of 2 is equal to 6. So if g of 2 is equal to 6, we have 1 over f prime at 6, which according to the table, f prime of 6 is 8, so our final answer is 1/8. Now that's what's happening with our table questions. So those are the two scenarios you're going to see the inverse functions, either in an equation or with a table. So that's it for Unit 3. Moving on to Units 4 and 5, those are going to be how we can apply derivatives in different scenarios. So we're going to pretty much, the whole basis is take a derivative and then use that to do something. All right, so as always, I appreciate you watching, and I'll see you next time for those videos.